Now let's build the circuit on the breadboard. Take one LED and place it on the breadboard so that two legs are in the different rows, like that. The longer leg is positive side or called the anode, and the shorter leg is the negative side or it can be called cathode. Now here is something very important. We need to use a resistor in series with the LED. Why? Because LEDs are very sensitive to current. If we give it too much current, it can burn out. The resistor limits the current flowing through the LED, making sure it blinks safely and lasts longer. A 220 ohm resistor or 330 ohm resistor is usually perfect for this. Here I have used a 220 ohm resistor. So connect one side of the resistor to the positive leg of the LED and the other side to a jumper wire and going to any digital pin of the Arduino. You can choose any pin. Here I used pin number 8. Remember, this is pin number 8. And the other side of the LED going to the ground pin of the Arduino. That's it. Now your circuit is ready. Go back to the Arduino IDE. Before we build the Blink code or upload anything to the Arduino, let's take a moment to understand the basic structure of any Arduino program. An Arduino program is called SKS, and every SKS has two main functions. Number one, setup. This function runs once when the Arduino is powered on or reset. It is used to set up things like pin modes or initialize communication. Think of it as the place where you tell the Arduino, hey, this is what I am going to use. Number two, loop. After setup is done, the loop function runs again and again continuously until the power is turned off. This is where we write the main logic of our project. For example, blinking an LED, reading a sensor, sending data, etc. Alright, now that we understand the basic structure of Arduino code, let's go ahead and create a Blink SKS. Inside setup, we write pin mode 8 output. What does it mean? Pin mode is a function that takes two parameters. The first parameter is the pin number and the second parameter is the role of the pin. Okay, the role means whether the pin will give the voltage or read the voltage. If it will give the voltage, the role will be output, and otherwise it will be input. In this case, we want to run an on and off LED. In the other word, we want to provide voltage to the pins. That's why we are defining this pin as an output. Clear? Okay. Now move on. The main loop. Arduino executes this function over and over again, as I mentioned before. Now, digital write 8 high. Question is, what does digital write means? In simple words, this function writes voltage or provide voltage to the pin. It has also two parameters. First on the pin number, of course, and second parameter whether it will be 5 volt or 0 volt. If 5 volt, you can write 1 or high or true. Okay, and for 0 volt, you can use low, 0 or false. So here I write high. Then a delay. If you want to force your Arduino to wait for some time, then you can use the delay function, where this value represents the millisecond value. So if you want to delay 1 second, then you have to write 1000 millisecond. Okay. Then digital write, eight low. Now it is clear for us why we write digital write 8 low, because we want to provide 0 volt to the pin number 8. Clear? You can use 1 or 0 also, no problem. Okay. And now if you want to blink the LED after just half second, then you write 500 and 500. Okay. Next job, select, first of all connect your Arduino to your laptop and select the board name and COM port correctly. Then click the upload button. Oh, semicolon missing, sorry. Okay, then after uploading, your external LED should start blinking, just like the built-in on did earlier, but this time it will be faster. Okay, because you use half second. Previously we used 1 second. Okay, great job. You have now learned how to control external components with Arduino, and you also learned why a resistor is necessary when using LEDs. In the next part, we'll explore how to use a button to control the LED manually. So stay tuned and keep building.